Well, welcome to my video. What I'm trying to go through today is to illustrate the problems I've had when installing these Digitrax SE8C signal decoders. So what's in the pretty box? Well, as you'd expect, you get the main board. If I can just zoom in a little bit. So here's the main circuit board, and on the circuit board you have eight separate drivers for driving each of the circuits. They say you can have 32 signals per board, but what it actually means is to obtain that, all the signals would have to be either red or green. They're kind of two aspect signals right through. When you get to more complex signals, you can only actually have 4 per driver, and these are called DVRs. I imagine that's short for driver, so driver 1, 2, 3, 4, 5, 6, 7 and 8. Also on here there's, as you'd expect, the 2 LocoNet connections and also a couple of switches. Normal standard BDL 168 type connector on the front. Also in the box is the normal standard instructions as you'd expect, sadly in black and white, and shows you how to run through the setup. Not the best instructions I've ever seen in my life, I must confess. A roll of the signal cable. This is a 10 core, obviously multi-core coloured cable, and a couple of these signal heads, which I imagine, obviously I'm from the UK, these are American type signal heads. And on top of that there's some of these connectors, and these are 2-piece connectors, and they simply connect up your signal heads to the ribbon as you run it on the underside of your layout. So what have I got on the table here? I've got a standard DCS 100 controller, a DT 400 handset connected up, a LocoNet cable, an old transformer that gives me 12 volts DC, and then just a couple of tools on the other side. So let's connect this up then. So standard LocoNet cable into there. The DT 400 is going to go into the SE8C rather than the controller, and then the fiddly old job, if you've done these, of fitting the connector block onto the circuit board, which is always a little, well, I find it always to be a little bit of a struggle. And there it goes. Right, all ready to go, so we'll power these up. And as it all bursts into life, I'll just put the power on here, power on. And then looking at the board, all we have is one blinking green LED, and occasionally the red one blinks. That's how it comes straight out of the box. All I've done is soldered on a couple of cables from the 12 volt DC transformer to make it run. If I zoom in, hopefully you can see these flashing LEDs at the back here. Yes, you can. Yep, there's those flashing LEDs. Right, how exciting. Now, next thing is as you read through the instructions, it mentions there the way that you need to configure the signal and which way you fit it, and it needs a couple of bends in the cable to get it to fit the right way around. So we'll fit this one to driver 1. I don't power these down when I fit these. It seems to work okay, but if you wish to power it down, then good for you. So I power that on, and then lo and behold, up comes the 2 red lights on the mast. When you read into the manual, it explains to you that really the best thing to do is to test this all out on a bench, and to fully understand the system before you go into battle. So when you pop it up on the bench, it explains exactly what should happen, and this is the standard configuration. So then it comes to how does a thing work? Well, you've got the 2 signal heads and on this one there's a green, yellow and red twice. But also, if you were to turn this block around and face it the other way, if you were to take this signal off of here and then place it in the other way around, okay, you get exactly the same features on two further addresses, which is how then you get 4 addresses per signal mast. For those of you in the States, this might be old hat to you, but I've never seen a signal like this. It's not something we see over here in the UK. So then you need to test it out, and the standard configuration for operating signals with Digitrax. So this one should be green on 257. So switch 257, throw, and nothing happens. Close, and it goes green. So that's on the top side. So throw, it goes red, and closed, it goes green. The next address on the top head is 258. So switch 258, throw, and the green goes out and the yellow is constant. But when you go close, the yellow then flashes, and that's how it works. Exactly the same happens on the lower aspect, also on the lower section of the signal. So if I go switch 259 and throw and close, so we go from red to green, and again switch 260, throw and close, and you get exactly the same reaction on the signal. As I said, if you disconnect it and fit it in the other way, you get exactly the same reaction from it. Now, the reason I've used the SC8C rather than the infrared detectors is because I've got bidirectional running on my layout. So what I didn't want to do is when a train comes through the opposite way of the signal, I didn't want the signal on green, and then as the train comes past the signal, facing the wrong way, it would then go red. It didn't seem right. So what I wanted was signals that I can control. I can switch either manually or with occupancy detection through something like Train Controller, so I could get them to run automatically and give a much more prototypical way of doing things. That's all straightforward. What you also need to do is to reconfigure the circuit board itself to ensure that, if I zoom back a bit, is to ensure that the ID number for the board doesn't coincide with any other board IDs. They all come through a board factory setting 01. Now that would conflict with my DS64s, which are 1, 2, 3 and 4. So I'm going to name this board 5, and then the signal addresses will all change. So it won't be the standard ones I mentioned earlier, which were 257, 258, 259, 260 on the front side of the signal. That would then move to 512 to 576. Now when you choose your board ID, you need to think about this quite carefully, because if you've got locos, let's say, that are numbered 513, then clearly having a board ID of 05 would mean that every time you change signal 513, you'd actually be doing something to your loco, or you might be throwing a turnout. So just try to make sure you deconflict when you pick out your board ID numbers. So that's what I'll do next, is change the board ID from 01 to 05 and see how we get on. That is dependent, of course, on me finding the right page. Oh, sorry, same page. Right. So press the. Now I mentioned before that there were 2 buttons on the circuit board. The outer one is the ID button, and the inner one is the option button. When I ran through this before with another board, when it said change using the option switch, I was actually using the option switch on the DCS 100 by mistake and starting to reprogram my controller rather than the board. An easy mistake to make, but obviously one hopefully you won't make. Now to change the board ID, page 8, pick yourself a board ID number that doesn't coincide with anything else on your layout that will conflict. If they come, standard setting is board 01. Now my DS64, one of my DCX has got a DS64 has got a board ID of 1, so I need to relabel it. Now I'm going to change this one to board number 5. Now the reason of that is I want to avoid certain ones, so I couldn't use board ID number 9 because it's in the 800s. Now I have a loco with an address of 812, and I wouldn't want to start making commands that would affect that. And similarly, if you've got points and turnouts with that kind of number, again, you don't want to conflict. So always pick a board ID, and this one here is from 513 to 576, and I have nothing within those parameters. Now, before you go to press it, what you need to do first is go switch 5 before you press the ID button. So I press the ID button and it should start to flash green, and there it goes. So I've put in 5 and then press a command of throw or close, it makes no difference, and that's the board ID should have changed. So now hopefully that signal now that's connected should change when I throw switch 513 as opposed to the earlier one, which was 257. So if I go, so switch 513, switch 513, throw and close. And hopefully you could see that. So that's throw and close. So there it is, going from green to red. And that's 513, so 514, switch 514, throw and close. Not quite. Is that working? 513, 514. Let me try that again. Switch 513, throw, it goes red to green. Switch 514, throw, close. Yes, it does. Gives you the flashing yellow. And the one underneath that should be 515, switch 515, throw and close. And there it goes, red and green. And then switch 516 again will give you the yellows. So there we end up with 2 flashing yellows. All straightforward really, but what you need to do when you change your board IDs is some fine gentleman on the internet sent me a spreadsheet for which to fill out your board, your ID numbers. Otherwise, it's quite easy to get into a pickle. You get a standard table within the instructions, and it shows you what goes on. If I can go to that one, which is this table here. But as soon as you change the board ID, then these numbers are no good. You have to then repopulate the table with your board ID numbers. And it's all straightforward. It's just a time-consuming exercise, really. So that's that one sorted out. Unless, of course, you happen to be in the UK. Now, this threw me for quite some time, because if I disconnect this signal and I connect a UK standard signal, and all these is a standard straight signal, which is red, yellow or green. There's no flashing on this, there's no upper and lower and all that palaver. It's just a straightforward signal. So what I need to do is I'll just disconnect the American style signal and install this UK style one. I'll just widen that a bit. Install the UK wide one, make sure I'm the right way around. No, I'm not. So that goes on the board like that. and then that one goes there like that, and that should be the same as the drawing. And of course, lo and behold, when I switch 5, 1, 3, throw and close, for some reason the red and green stay on and the yellow flashes, if you can see that in there. Let me just go a little bit tighter. Which is obviously nothing to do with what I want from the UK. And the reason is, for some reason, the Digitrax system is designed on a common anode with LEDs, where back in the UK, and I imagine the rest of Europe, we're on a common cathode. So it only took me the best part of a whole day to figure this out. So what you need to do is you need to make another change that's buried in page 23, to change it to common cathode. Now what I've done, as you can clearly see, is the changes that I've made to the system. Let me just zoom back out a bit. The changes that I've made to the system, I've highlighted in the manual, so I know what I've done, so I can, I can figure out, if I need to change things, or what exactly I've done. So what I need to do is you change the 2 banks of 4. So you've got drivers 1 to 4 and then drivers 5 to 8, and they come in 2 batches. So you can change one set to common anode, or both sets to common anode or to common cathode, or half of each or whatever. And you do that through the op switch, which is not the op switch on the DCS 100. It's not this one here, but it's the op switch actually on the board. I couldn't get my head around that at first. I was clearly going down the wrong avenue, but I sorted it out in the end. And the other thing, of course, that we don't have in the UK is we don't have a flashing amber. So the options there is when you throw the flashing amber, it just goes yellow. When you throw it, it goes yellow, but when you close it, it doesn't flash. It simply goes off, which is what we want. So I'll just try and attempt to do those now. It'll be closed. So there's the red light, and so op switch 5. So you go switch 5, then press the op switch button on the panel until the LEDs flash alternately. Op switch 5 is a close. Then you have to press the op switch again until it goes back to the standard green LED only. So the next, that was the closed. The next closed is op switch 8. So switch 8 back onto the panel, and that's a close. And then finally is op switch 9 is a closed. So come back off. No. Great. So op switch 9, switch 9. Turn the option switch on. Op switch 9 is a close, and then come back off of the op switch mode. Now hopefully, if you can see this red light, which should be 513, so switch 513 is throw or closed. Let me have a look. Yep, red and green. Okay, that's the standard way it is in the UK, that you either have a red light or a green light, or you have a yellow light. Now to switch the yellow one, which is 514, switch 514 should be throw, and when you throw it, the other 2 lights from address 513 will go off. So the red and green go off, and when I throw it, normally it would be flashing amber, which we don't have in the UK, so this one will always stay in the thrown position. And then when I switch 513, so switch 513, then I can choose from red or green. So as soon as I throw the red, the yellow goes off, and the red goes off, and that's the standard UK configuration. Obviously, if you're in the US, I don't know how it is with Canada and Australia, the main users of this system. You probably don't need that because you may well have common anodes, but in the UK at least it's common cathodes, and hopefully there's some kind of understanding of how that works. Just to sum up really is it all kind of works, it's all straightforward really. Everything in the box is what you need. Obviously you need to hook up all this cable, but you have to test your signals and get it sorted out, and then a clear understanding in your own mind of how it works before you go through onto the bench. As I said earlier, the standard signals that you get supplied are these kind of US mast type heads, and then to convert these into the UK ones, it might seem a little drastic, but all you simply do is cut the head off, obviously throw that piece away, and then you have the contacts on the back to solder your signal heads. If you look at the back of the signal heads, then the top 3 LEDs run down to those contacts, whereas the bottom 3 LEDs run down to those contacts. It's all kind of straightforward really. It's just it might test your soldering skills a little bit, but I'm no great solderer, and hopefully from here you can see that it's not that it really isn't that difficult. I don't know if I can come in and show you that. So there's my soldering on there. It's all kind of straightforward. So there we have it really. Hopefully that's been useful if you're into these this way of controlling your lights with the SE8C from Digitrax. I know from other companies also use it on their kind of LocoNet systems. So hopefully it'll be some use to you. And I'll see you at the next video, so don't forget please to like and subscribe. And that's the end of that. Thanks. Take care. Bye-bye.